Osteopetrosis and Erlenmeyer flaciformity by Marlon Molina. Definitions. Osteopetrosis. In osteopetrosis, bones are too in size but easily broken. This happens when new bones grow faster than old bone is removed. Bone that is too dense can cause serious problems throughout the body. It can also cause problems with the bone marrow, tissue inside the bones. This video.
Osteopetrosis. Osteopetrosis, also known as marble bone disease and Albers-Schonberg disease, is a rare disease caused due to improper functioning of osteoclasts resulting in harder and denser bones. It is an inherited disorder. Bone marrow transplant is the most commonly used treatment for osteopetrosis.
Erlenmeyer flaciformity in the series is EFD is a long-standing term used to describe a specific abnormality of the distal femoral. The deformity consists of long modeling of the deep metaphysis with abnormally cortical thinning and lack of the concave deep metaphysis curve, resulting in an Erlenmeyer flash-like appearance. The video.
This is a quick radiology, and today I'm going to talk about what are the causes for Erlenmeyer flask deformity. Come on, this is 2 minutes radiology, that's it. If you see a word Erlenmeyer flask deformity in USMLE or any other medical board examination, what are the causes that it should strike your mind? Come on guys, this is for a entrance preparation for your USMLE or for any other medical examination preparation. Remember, one is a Piles disease. Nothing but metaphyseal dysplasia, that's known as metaphyseal dysplasia. Okay, thalassemia, very important, very important. Thalassemia, Erlenmeyer flask deformity seen in thalassemia. Osteopetrosis, then we have what you call Gaucher's disease. Okay guys, so what are the causes for Erlenmeyer flask deformity? Pell's disease, that is a metaphyseal dysplasia. Okay, metaphyseal dysplasia. Thalassemia, really very important, and the osteopetrosis and Gaucher's disease. Okay guys, these are the important causes. There might be plenty of causes for that, but for USMLE, try to remember these things. Okay guys, thank you so much for watching this video. Take care.
Applications in medicine. The video.
In this video, I would like to go over the pathophysiology of different bone disorders and then discuss how the lab values for the serum calcium, serum phosphate, alkaline phosphatase, and parathyroid hormone will be affected in any one of these conditions. But before being able to discuss these conditions, first I would like to go over the physiology of the bone formation as well as bone structure as well as the cells and the hormones that are involved. So the bone is made of a combination of calcium and phosphate that is combined with hydroxide, and they would form the hydroxyapatite, which is highly resistant to fractures. Now the cells that are involved in the formation of bones are osteoblasts, while the cells that are involved in the destruction of the bones are osteoclasts. And it's the osteoblast that will send signals via rank L as well as the macrophage colony stimulating factor to induce the monocytes to be converted into osteoclasts. And osteoclasts, in order to be able to destroy the bone, they will secrete an acidic solution, an acid will help destroy the calcium components and dissolve the bones. And then on the other hand, osteoblasts, which are forming bone, since acidic environment is destroying bones, they would require an alkaline environment to form the bone. And so alkaline phosphatase, or ALP, is a component that is used to determine osteoblast activity. Now, one hormone that you have to be familiar with is parathyroid hormone, which will overall increase the calcium concentration of the serum and decrease the phosphate concentration of the serum. And parathyroid hormone regulates the calcium concentration via different mechanisms, including one, it stimulates the osteoblasts to secrete rank L as well as macrophage colony stimulating factor to form more osteoclasts, and so therefore there would be more resorption of bones. In addition, parathyroid hormone induces the activation of vitamin D, and
It is caused by failure of osteoclast differentiations or function mutations. Osteoclasts are highly specialized cells which segregate bone mineral and organic bone matrix. These processes are crucial for the bone remodeling and the maintaining of the bone biomechanical stability and the mineral homeostasis. Pro and cons. The video first.
Alright, let's talk about osteopetrosis. Osteo means bone, petrosis refers to rock-like. So this is a disorder in which you have abnormally thick, heavy bones. It's an inherited defect in bone resorption. Now, if you remember, bone formation is a balance between osteoblasts, which lay on bone, and osteoclasts, which resorb bone. Now, this balance is constantly occurring throughout life so that you're always laying down some bone and always resorbing some bone. Now, a defect in bone resorption in which you're constantly laying down bone but can't resorb it results in an abnormally thick and heavy bone. Now, despite it being abnormally thick and heavy, it fractures easily. Think of it like a piece of chalk. A piece of chalk is thick, but you can easily crack it. Now, this disorder is due to poor osteoclast function. It has multiple genetic variants. Most important is the carbonic anhydrase 2 mutation, which results in a lack of acidic environment that's required for bone resorption. An acidic environment is necessary in order to remove calcium to resorb bone. Now, in order to generate an acidic environment, the enzyme carbonic anhydrase is necessary. Carbonic anhydrase combines water and CO2 to make up H2CO3. Carbonic acid then breaks up into a proton and bicarbonate. Now, this proton, which is the acid, leaves the cells, and this is what creates the acidic environment necessary for bone resorption. If osteoclasts don't have the ability to generate this acidic environment, they won't be able to resorb bone, and this is exactly what occurs in the carbonic anhydrase 2 mutation. The clinical features of osteopetrosis include bone fractures. Now remember, although the bone is thick, it's going to be very weak, hence it's more prone to fractures. And this is because there is no proper balance between the osteoclasts and osteoblasts. And in order to make strong bones, you need to have a balance between the osteoclasts and osteoblasts. Patients can also have anemia, thrombocytopenia, and leukopenia. So now this occurs because the thickening of the bone replaces the medullary space, which is called a myelophysic process. Myelophysic process which knocks out the ability for hematopoiesis. Hematopoiesis, which means generating blood cells. So if hematopoiesis is knocked out, individuals end up with anemia, low red blood cells, thrombocytopenia, low platelets, and leukopenia, low white blood cells. These individuals end up with extramedullary hematopoiesis, so these blood cells are going to be made outside of the bone marrow, either in the spleen or the liver. Patients can also develop vision and hearing impairment. This is due to the thickening of the bone that compresses the cranial nerves as they try to exit the skull, and hence they end up with these impairments of vision and hearing. Patients present with hydrocephalus. This is due to thickening of the bone at the foramen magnum. Patients can also develop renal tubular acidosis. This is when patients develop metabolic acidosis within the blood due to a defect in the tubules. This is seen with a carbonic anhydrase deficiency. Tubular cells have the ability to take water and CO2 to make H2CO3 in the presence of carbonic anhydrase, which catalyzes this reaction. Now, H2CO3 breaks into H plus and HCO3 minus. The hydrogen ion transfers into the lumen and joins with NH3 to form NH4. This is important because it can be excreted, getting rid of acid. When you get rid of acid, this results in a net gain of bicarbonate, which goes into the blood, maintaining pH of the blood. So it acts like a buffer. Now, if you don't have carbonic anhydrase, you won't be able to generate this acid, and therefore you won't be able to excrete this acid, and you won't be able to get the net gain of bicarbonate. So these individuals become acidotic. Now, what is the treatment of osteopetrosis? The treatment would be a bone marrow transplant. Now, you may ask, how would a bone marrow transplant help? Well, think of it this way. The problem in these individuals is that their osteoclasts are not functioning properly. Now, an osteoclast is a macrophage in bones, and macrophages are derived from monocytes. Monocytes are derived from the hematopoiesis process. Hence, a bone marrow transplant will give this individual the ability to make normal monocytes, hence generating normal osteoclasts and taking care of the problem. In summary, osteopetrosis is an inherited defect of bone resorption that results in abnormally thick, heavy bone that fractures easily. Now, this is due to poor osteoclast function. This may be due to multiple genetic variants, one of which is the carbonic anhydrase 2 mutation that leads to loss of the acidic environment that is required for bone resorption. Now, clinical features include bone fracture, anemia, thrombocytopenia, and leukopenia with extramedullary hematopoiesis due to the bony replacement of the marrow, which we said is called myelophasic process. And these individuals present with vision and hearing impairment, hydrocephalus, and renal tubular acidosis, and the treatment is bone marrow transplant.
Pros. Life expensive in adult onset forms is normal. Treatment is large, supportive, and is aimed at providing multidisciplinary surveillance and symptomatic management of the complications. Cons. Nowadays, no effective medical treatment for osteopetrosis exists. Fractures and arthritis are common and requiring treatment by an experienced orthopedic surgeon due to the brittleness of the bones. Insights in Ecuador. In Ecuador, science is not easy to find instrument to detect osteoporosis. That means that the prognosis of life is low. People have to go to another country and pay for the proper exam to diagnostic osteoporosis unknown and other bone designs. Thank you.